All right, so let's get started. Before I get started, I want to ask you a question. Who here has ever stepped outside, just stopped what it was they were doing and thought, what an amazing time to be alive? All right, well, that's a good portion of the class. Excellent. Well, that's hopefully what we're going to reinforce today. But just to get you started about what an age it is we live in, this week in science alone, I just want to share with you some of the updates that are happening in the world of technology, science, healthcare at large. So this is just briefly from skimming the web, BBC News. University of Washington researchers created and demonstrated the first documented case of mind control. Now, this is really exciting. What they did was they had the lead researcher, Professor or Dr. Rao, in one room across campus, and then they had his associate in another room way across campus. And what they did was using very simple yet sophisticated brain mapping techniques. So what they did was they strapped on an EEG onto Dr. Rao that read his brain waves, and specifically when he thought about moving his hand to launch a rocket, the computer recognized that specific manner of patterns to move his hand to launch a rocket in a computer game. Now, this was transmitted via internet to his subject across campus, who was wired to what we call transcranial magnetic Doppler. And it transmitted the signal to his hand to move it involuntarily to push the space bar on a button on a computer game to launch a rocket. And so things of science fiction that we once dreamt about when we were kids about mind control, whether for nefarious or for beneficial causes, has come to be. Elsewhere in the realm of science and the world at large today, University of California researchers have demonstrated that what our parents and doctors have all along told us is true, that if you go on a health kick, that is, eat right, take care of your stress levels, and get enough sleep, that you can actually change your own aging process down to the cellular level. So what they did was at the University of California, they studied patients with prostate cancer, and 10 of them, they said, you have to go on a strict vegetarian diet, to exercise regularly, and you have to meditate to control your stress. And then they studied them over the course of many years, and they found that the telomeres, these are, for those of you not familiar with cell molecular and biology, telomeres are a measure of, I guess, how you age. And so they found that as you age, telomeres tend to shorten, that in fact this process was reversed, and these people who lived healthily actually had longer telomeres than those who didn't. So there you go, the world of science. And then the last thing I want to talk to you about, just in this thesis, the world is amazing. In the University of North Carolina, they are actually printing 3D mini organs. So they're inputting a design into a computer modeling system, and then they're giving them bioink, that is cells, and saying, we want to print a mini kidney or a mini heart or a mini liver, and then testing vaccines on these models of human organs. So if you aren't convinced that this is an amazing time to be alive, hopefully this will push you in the right direction. Okay, so that was kind of an introduction to what we're going to be talking about today. Today is all about engineering tomorrow. Specifically, how do we get from here to there? How do we get from thinking about big ideas, thinking about what is possible, and we'll spend a good deal of this lecture talking more about that, and then turning that want to create the next revolutionary idea, or the next big thing, and look at themes that come up frequently in big ideas, in actors of these, whether they're entrepreneurs or inventors. Okay? So one of the theses, if you remember nothing or little else from this lecture, if you go for a bike ride in your mind for the rest of this lecture, I want you to keep in mind that the world is amazing and there's potential in everything and everyone. And so for those of you who need further explanation, who don't quite believe me, I'd like to introduce you to Makey Makey. Yeah, for the rest of you who are interested in seeing the rest of that, that's called Makey Makey. It came out of MIT Media Labs. But what I want to show you through this video is that there is potential in everything and everyone. So anyone has the potential to be an innovator, an entrepreneur, or a creator, and anything, whether it's bananas or staircases, have the potential to become anything else, like a piano. All right, so let's start with one of the first of two big themes we're going to concentrate on during this class. So let's talk about big ideas and how we get there. Okay, so first of all, I'm sure a lot of you have this burning question: who are you? Okay, so let me tell you a little bit about myself, but first, I also want to turn the tables on you, and Kim knows this, I do this every class. I want to know more about you. So what we do at this point is go around, and I want to find out more about who you are, what you're studying, maybe you're interested in taking this class.
So,
You can start in the front row.
Hello, everybody. My name is Brad. I'm actually in my 6th year of my undergraduate degree, so I'm a bit of a late bloomer, I guess. I'm just taking this class because I find the subject matter very interesting. I'm a political science major myself, and yeah, I think it's just going to be a good time. So.
Yeah, I'm Jeffrey, and I'm in sciences, and I'm in my 4th year, and finally got the option to take some electives, and I heard about this course from the students in the older years of my program, and I'm always interested in new technology, science fiction. Maybe people don't like that word being used in this class, but I guess that's what drew me to it.
Hello, my name is Heng Jia. I'm from China. I came to Canada last year. I major in honor science in biochemistry and pharmacology, and I take this course because I plan to do some medical field research in the future. Hopefully, this course can give me some more idea for my future research.
hi, my name is Siraj. I'm in my last year of sciences, and I took this course because I liked, I guess, the way it was structured. It goes beyond the textbook, and it touches on a lot of things that you wouldn't be able to find in a lot of other courses, right? It's pretty unique, so I thought I'd take the advantage of it.
Hi, my name's Opie. I just finished my commerce degree, and I'm hoping to get into grad school in September. I took this course because a friend of mine took it, and he loved it. He highly recommended it, and I'm hoping to learn a lot.
Hi, very loud. Hi, I'm Nolan. I'm formerly computing science, now out in the alleged real world, yelling at computers, and occasionally they do what I tell them to. And I'm very interested in where the future of that is going, so I'm fascinated in this course. Thank you.
I'm Ross. I'm just finishing my PhD in physics, and my reason for joining the course is to broaden my horizons while I'm looking for the next step in my career.
My name is Jason. I'm upgrading a Bachelor of Science, and I'm learning what has changed over the last 20 years and looking to see what I'm going to do in the future.
My name is Vibu, and it's my first year for undergrad. I'm trying to go to med school, and I'm not actually in this class, but the workshop seemed interesting, so I decided to come.
My name is Shawna. I'm in sciences, planning on going into computing science. I'm not actually in this class, but I came for the workshop because it sounded interesting.
My name is Paneet. In my 3rd year of a BSc program in general, and I took this course because it sounded really interesting, and the people that are teaching it or leading the sessions, they're really inspiring, and some really cool stuff like that.
My name's Savina, and I'm in my 3rd year of BSc General. I'm actually not in this class, but he was telling me about the workshop, and it seemed really interesting, so I decided to come.
Hello, my name is Anson. I graduated from mechanical engineering in 2007. I worked a few years and got my PhD, and I just came back for a Master of Design in Industrial Design. I found out about this lecture from the new student group, Innovation Lab. That's why I'm here.
Hi, my name is Aisha. I graduated a year ago with the Bachelor of Commerce, and I'm in environmental sciences as a special student, working towards my master's, which I'll start next year. I took this course from recommendation of a friend, and I think what we'll be learning, and especially in singularity, which I'm interested in, is kind of applicable to a lot of further education, so I'm hoping to kind of see where that goes.
Hi everyone, my name is Camille. I'm in my 5th year of my undergrad. I didn't know this was a course. I got an email from the UIL, and seeing as I'm a spontaneous individual, I decided I would just show up and see what this was all about, so I'm hoping to be impressed.
Hi, I'm Nathan Carroll. I'm also not in this class. I got the email from Shawna through our listserv to attend this one on Thursday's workshop as well. I'm in medicine and a former business owner as well, so I'm very interested in entrepreneurship and innovation in medicine. In the first couple of years of medicine, the timing didn't work out, and so I'm rotating through psychiatry right now, and I escaped and came today, and I have to leave in just a little bit, so sorry for leaving shortly.
Bending the rules is always encouraged.
Hi, my name is Ambreen. I'm not actually in this class. I'm just here to sit on the lecture.
Hi everyone, my name is Akib. I'm not in this class either, but I was invited here by my buddy Suraj.
Okay. So I think that's it, right?
Awesome. Well, it's great to see that. I always like to know who I'm talking to. It's awesome to see that we have everyone from first year of undergrad to finishing their PhDs to various stages in their medical careers, poli-sci students, science students, so whole plethora. That's awesome. So fair is fair. So you guys told me about yourselves, so I'd like to tell you about myself now. So my name's Shawna Pandya. I'm a second-year neurosurgery resident here at the University of Alberta. The rest of my background is quite a grab bag of things. So previously I've spent time in the space sector, having earned my master's from the International Space University, and then having spent time at NASA's Johnson Space Center and the European Astronaut Center. That's kind of where I got my interest in space technologies that have spin-off applications for benefit in medicine here on Earth. And I've actually written a book chapter on it. Very passionate about technology, big ideas, spent some time down at Singularity University down in Silicon Valley. And that's where I founded my company, CivicArt, based on disaster response technologies and helping do mass messaging better. Most recently this year I've been a TED-Med frontline scholar. That's me in a nutshell. So now we know each other. All right. So the interactive part isn't done yet. What is this? Anyone? It's not a trick question. It's a stretch of highway. Excellent. It's a road. Okay. And so one of your first of many optional homework assignments following this class is to just go outside, stand near a road. Don't stand in it. Stand near a road and just marvel at it. And just take the time to appreciate how amazing this simple stretch of infrastructure that we take for granted is. And then think about what went into the creation of roads and highways. And take a step back and think of what we use roads and highways for. So this is a segue into my next question. Who is this gentleman here? Does anyone know? Exactly, this is Henry Ford, and he is the man who not invented, let's be clear, he did not invent the automobile. Various versions of the automobile had been around since as early as the 1600s in its very first prototype. But he was the gentleman who mass-produced the car. And what his thinking was in mass-producing the cars, he wanted to produce something that was inexpensive, high quality, at the same time providing a high wage for his workers. So he's the one who is single-handedly responsible for transforming the very physical geography of our planet. Things that can be seen from high above. Next time you're on a plane, just look down and think how one single person's aha moment saying, what if I could mass popularize or mass produce the car, physically transformed this planet. So let's take another example of things we take for granted. Who and what is this? Yeah, exactly. Thomas Edison and the light bulb. So again, the point I want to drive home here is that this is something that has changed and transformed a very society. We no longer get up and go to sleep by the rise and setting of the sun, but we are a 24/7 society thanks to the light bulb. Yet again, this wasn't a single idea of one person who had this aha moment and said, what if we had light 24/7? Rather, he was a culmination of many before him, from Humphrey to Israel, who had worked on this concept of creating a lasting source of light beyond natural light. And even before him, there were kerosene lamps and flames like flames and other sources of light. But what Thomas Edison did was he persevered and looked through existing models of light bulbs until he finally found two things that really helped make the light bulb as successful as it was. He chose tungsten for his filament, and he also took the light bulb as part of a whole system. So he didn't just think of the lamp portion of what it takes to make a light bulb, but thought about the circuitry behind it and the generator as well. And this can be, these examples aren't just limited to things that we kind of take for granted in our background. They're also go as beyond the light bulb, beyond the car, to airplanes. So before we move on to the next slide, what are other things that have revolutionized or changed the way we live, whether specific to your own field, for example, science or medicine? Someone held up a smartphone, yes. So any examples from you guys? Internet, yes, exactly. Anyone else? All right, so just to throw out a couple examples, vaccines have changed the human mortality along with prevention campaigns. So simple introduction of hand washing has drastically cut down on the amount of mortality, whether it's related to obstetrics and healthcare, and child delivery, or in the operating theater, my own field. The simple introduction of sterile measures and precautions has changed survival. And in fact, if you look at life expectancies centuries ago, before we were ever even thought about washing our hands, humans used to think it was normal to live until 30 and then die. For us, that would be a tragedy if someone died at that young. Anesthesia, again, coming from my own field, we would not be able to do what we do today as surgeons, whether you're talking about removing a complex tumor to removing an appendix, without the effects of anesthesia and being able to put the patient under for hours. And so I've kind of talked to you about innovations that have changed our world, but let's take another thought experiment and imagine what life would be like without any of this. So I'd like to call your attention to this article I came across this week. You can Google it. The headline says, "Wealth Family Lives Like It's 1986." And this is just fascinating. So they're family out of Ontario, and they have 2 young kids, 2 and 5 years old, and they noticed they couldn't tear them away from their iPads and iPhones. And so their parents thought, well, what if we just lived like it was the year we were born, 1986? And so this article tracks the reporter as they go into these people's house and enters their lives and notes there's no smartphone, no internet, no cable TV. The most high-tech piece of gaming equipment is a Nintendo 8-bit system, and their most elaborate form of communication is a fax machine. So just a thought experiment, or even second piece of homework for you, if you choose to engage. For a day, shut off all communication. Maybe let people know that you're doing this so people don't call the police. But just imagine what life would be like without revolutionary things that we take for granted, like the internet, like smartphones, like cable TV, or even with a normal cell phone. Okay, so then I want to spend the next part of this class talking about things that are happening today that are amazing. We aren't invented out. And so one technology I briefly mentioned at the intro of this class is called 3D printing. Has anyone heard of it? Hands up if you've heard of 3D printing. All right, good portion of you have. So for those of you who aren't familiar with this process, 3D printing is essentially using computer modeling to design whatever it is you're out to design, whether it's artwork, a house, an organ, inputting those parameters, inputting your material, your base building material, and then printing out your finished project. And so people are doing this with everything from plastic to print out action figures and pieces of art and curiosities like this fractal sphere here, to more complexly, in a more sophisticated sphere, actual human organs. And they haven't gotten as far as replicating some of these complexes of the brain yet, but we aren't far off, and you'll see examples for example, like these mini organs that I talked to you about at the beginning of this class that are being printed on a chip, that are being used to replicate and model the human body and its responses to vaccines, to toxins, to treatments. Even more impressively, on a bigger sphere, one particular group I worked with and met at Singularity University asked, what if we could 3D print houses? So for 70% less material, less cost, less waste, using local materials, whether you're in sub-Saharan Africa and only have clay and adobe, to in the developed world in North America and using lumber. What if you could input your ideal house and then put in the basic building parameters and print houses? So this idea is still in development. It's viable. They just have to they're researching to overcome several technical hurdles, like building up their walls before the cement sets too quickly. But these things are being done out there today. And these ideas aren't decades away. So on the other end of the spectrum from thinking big, think of the very small. Maybe not everyone has asked themselves this, but I'm sure at least one of you has thought, what if I could manipulate the atoms themselves? Anyone ever thought that? Yeah, I see at least one person nod. So this here is out of Research University in Vienna, and it is a nanoscale model of a church used, in this case, it's, I think it might be iron atoms. But the point of this slide here is that once you can manipulate the atoms themselves, the sky's the limit, whether you want to engineer new molecules or rebuild the Sistine Chapel at a nanoscale, if that's your thing. And for those of you who grew up on the Jetsons, who wondered when we'd have our flying car, again out of MIT in Boston, there's a company called Terrafugia, building exactly that. And they've got FAA clearance and started testing on a hybrid car and airplane model that can just as easily drive on highways and take off if traffic seems too busy. Coming back now more towards the sphere of this course, Technology in the Future of Medicine. Has anyone here heard of the DARPA prosthetic or DARPA robotic arm? A few people have. Okay, so this was a challenge issued by DARPA in the early 2000s, and basically the thinking of this was, we have so many veterans who've served our country. For those of you who don't know what DARPA is, they're the Defense and Research arm of the United States military. And they said, well, we have so many veterans who've served our country who have sustained horrible injuries, yet for a lot of them, the best we can do in terms of prostheses is a hook, which has been around for centuries, or a plastic, non-functional arm that looks like an arm but doesn't really do anything. And so they issued this challenge to neurobiologists and researchers to come up with something that was better. And one of the outputs of this competition was the DARPA prosthetic arm. And so with videos, I haven't included one here, but with videos you can see the finesse with which these soldiers can move their arms, exhibit the same amount of degrees of freedom, that's the term we use in robotics, to move, to describe what axes you can move an object within. And so it's very comparable and in fact almost better than a human arm, and it's pretty impressive because you can watch these soldiers begin to pick up objects, again, pick up spoons, even feed themselves for the first time, and even catch a ball, which requires an immensely complex series of movements, from processing that something's been thrown to seeing it, to transmitting that visual stimulus to your motor cortex, then transmitting that out to your arm to actually enact your arm to move to catch it. But they can do it with this arm because it's connected to the remnants of the nerve plexus in these soldiers' and patients' arms. For those of you who are also interested in advanced prosthetics and prostheses, exoskeletons. So again, initially engineered for patients who are debilitated, for example, paraplegics. These exoskeletons, this one comes out of Berkeley Research Labs and consists of an external backpack that bears the load of the patient and allows them to have a support structure, enables them to walk by providing an outside structure as well as robotic legs. So now switching spheres from medicine to my other passion, space. So has anyone here heard of the Mars One project? Who applied? No one. Okay, so Mars One is one dreamer. He's from the Netherlands. It's his answer to why haven't we gone to Mars yet? So basically, they formed this organization around creating the biggest media blitz to document the journey from going towards Mars, and basically the end goal is to create an initial settlement of humans on Mars. And the website's Mars One for those who are interested in learning more. And so they just finished their first round of soliciting applications from the whole wide world. I think they collected over 200,000, and the idea is to whittle it down in a reality series style contest, hopefully more friendly than Survivor. And ultimately choose the first trek of humans who will go colonize Mars. Okay, so one of the last things I want to tell you about is for the material scientists and materials engineers out there, it's called aerogel. Switching spheres again. So this is called aerogel. It feels like styrofoam, but if you were to hold it in your hand, it would feel almost weightless, and you would barely be able to see it because it is so light in its structure. And so its claim to fame is that they call it weightless or frozen smoke, and that despite being so light, it is actually capable of withstanding forces 4,000 times heavier than itself. So here's an example of its application. Barely visible, it's holding up a brick here. Virgin Galactic, for those of you who are following this company, is one of the first, in fact, one of the only companies right now working on private spaceflight for those of you who've always wanted to go to space but never really applied to be an astronaut. So just wait a couple years and you'll be able to buy your ticket to space. So why am I telling you all this? Why am I giving you examples from material science, from space, from aviation, from medicine? The point is, and this goes back to what we were looking at with Edison and Ford before, is that big ideas happen, but they don't happen overnight. They happen by building on the ideas of others, by persevering and following these ideas through thick and thin, and daring to dream, but also daring to do, and that's important too. So, for example, looking at those of you who've been following Virgin Galactic, that company's been going strong since 2002 when it first won a challenge to create suborbital flight, or to successfully go to suborbital flight and land again. But it's not an overnight success. I mean, here we are almost 12 years later, and they're still slowly edging their way towards making space travel a reality for the non-astronaut. Okay? So for the second part of this course, we're just going to talk about what I call fairy tales from far-off labs or not. So I want to tell you about my own experiences in far-off projects, and then we're going to bring it all home and talk about the themes that we can extract from this and what it is that have been the commonality between all these amazing inventions that have brought them from here to there. So I want to tell you about my experiences with the NeuroArm project. So for those of you who love robots and for those of you who love brains, there's robots who do brain surgery. So this was a project out of the University of Calgary, and the surgeon who partnered with an engineering firm to make this said, well, humans are pretty good at brain surgery, but we're not perfect. We have tremors that, you might not be able to see except under a microscope, but it does make a difference. We have a limited scale at which we can operate. For humans, that's millimeters. What if we could do better? What if we could eliminate that tremor? What if we could operate at the micrometer scale? And so this is a project called NeuroArm, borrowing on some technologies from Canadarm. And it essentially is the first intraoperative MR-guided neurosurgical robot. So that means it can take MR pictures of your brain during surgery, as well as eliminate tremor, keep locked on a single axis, and operate at smaller scales. Switching over to the space sphere, near-Earth asteroid missions, long-term space flight, that's kind of the human dream. That's kind of what captures people's imagination. The moon landing was the first such big human grandiose feat, and people have been waiting for that to be replicated. And now the question is not when do we do it, but where do we go next? Do we go back to the moon? Do we try to build a base there? Do we try to go to Mars? Mars One's trying to do that. Or do we venture even further and try to visit an asteroid? So bottom line, it's being done today. So this is the work I completed with NASA at the Johnson Space Center, and it was called the Exploration Medical Capability. And basically what we explored was, hypothetically, if you're going to an asteroid and you're taking a 9-month long-duration flight, what are your first steps? From a medical perspective, what are your first steps? What do you need? What's likely to come up? What would be an end game scenario and cause you to evacuate? What could you deal with? What would need to be treated? And for an added challenge, how do you do all that with limited mass and volume constraints? So that's what we worked on. And we worked on creating a medical kit that could address the majority of things that were likely to come up with certain constraints. And we'll spend the last part of this section talking about big impact. So my company is called Saviguard, and I'll tell you a little bit more about what it does now. So this idea came out of a challenge from Singularity University to positively impact 1 billion people in 10 years using accelerating technology. And so I worked with a talented team of 9 people from 7 countries. That was us there. And we took one step further and said, how do you positively impact 7 billion people? What if there was a way to what is a problem that affects anyone, anywhere, anytime? And we came up with disaster response. And then we asked ourselves, what needs to be done better? And so when we looked at the commonalities, whether you're talking about earthquakes in Haiti to bomb scares in Times Square to devastating floods, the commonality to us was mass messaging. And we looked at the existing systems out there that were prone to failure, that gave out generic messages and not in a timely fashion. And to give you examples of things already in place, the San Francisco and San Mateo County area warning system said, National Weather Service has issued a blizzard warning. Okay, so great, there's snow. What do you do about that? During the 2010 Times Square bomb threat, the Office of Emergency Management in New York issued a response that said, Broadway is closed between 44th and 46th Street. But what do you do with that information? If you're nowhere near that region, how does that help you decide, or how does that help you in your day? And if you're near that region, where do you go next? How do you get out? So we looked at trends, we looked at emerging technologies and what we could capitalize on, and two things immediately struck us. First of all, social media. So this is in 2007, at the beginning of, or 2009, just as Twitter was coming out and becoming big. And so if we're looking at the trends, Twitter had 100,000 users in 2007. At the same time, there were 2 million smartphones in existence in 2007. That number leapt exponentially between 2007 2009. So Twitter exploded, jumping to 15 million users and into the hundreds of millions today. And in 2009, there were 30 million smartphones, orders of magnitude, one order of magnitude higher. And looking at projections, there's projected to be 3.8 billion smartphones across the planet in 2015. There weren't even that many people around in the 1960s, so that's pretty staggering figure there. So now that we had a problem space and emerging technology, our question was, how do we marry the two? And so that's when we asked, what if a smartphone could save your life in a crisis? And so this is a simplified architecture, but essentially what we did was we created a command-side console and a user-side console. So for us, if we were trapped in quad and there was a gas leak nearby, those of us who have smartphones would get messages from the command side saying, hey user, we see you in the area, there's been a gas leak, here's what you do and here's what you go next. Here's some proposed evacuation routes, here's nearby shelter information, medical aid, here's potential first aid information. On the command side, we created a tool that allowed any Office of Emergency Management to select areas by specificity, whether it's by a zip or zip code, postal code, by even just selecting it out on a command interface, or by saying specifically University of Alberta area versus downtown Edmonton. And so what we did was, first of all, we realized the importance of, going back to our first principle, daring to dream, but then daring to act. And so what we did was we built an initial quick and dirty prototype and then told people about it. And so we managed to go to the White House and talk to their Office of Social Engagement and Innovation. We talked to Google.org. We talked to the members of the UN Emergency Communications Committee. And then we launched our first pilot in the city of Manor, Texas in 2010. And we managed to also tell people what we're doing, get people excited, get people engaged about it. So we're covered in Inc. magazine, Entrepreneur magazine, Popular Science. And in so doing, we were able to get even more people interested in what we were doing. And so the lesson, one of many that we learned, was to act fast and to always dare. And so we kind of repeated that when Hurricane Irene came about in 2011. In the space of 7 hours, when New York was creating hurricane evacuation zones, we called our developers over who were situated in France, Germany, and of course the US, and we said, this is what we want to build. Can you do it? And they were game, and they created a map that essentially targeted where you were and said, hey, you're in an evacuation zone, this is what you need to do, or you're okay. And so I was in California at the time, so you can see it says you're safe. You do not need to evacuate. So that was good. It worked. Okay. So as we're winding down, I'd like to bring everything that we've talked about together. So what are the lessons? What are themes? How do you go from creating pie in the sky, dreaming about pie in the sky ideas, and how do you turn them into reality? So just an initial plug. So we're going to just touch on the ideas to reality part today. Next week's class is much more interactive. It's a workshop, and the focus will be on you taking your ideas and making business out of them. But today we're just going to talk about themes, okay? So the first lesson I want you to talk about, or to take home with you, is nothing is impossible and impossible is nothing. If you can dream it, you can do it. And so homework assignment number 3, I hope you're at least thinking about starting to write these down. Go outside and ask yourself, what can be made better? Look for inefficiencies in the world around you, whether it's the way that quad is designed, for example. Is that necessarily most conducive for helping students get from class to class during classes? What about building design? What about bathroom design? Is it necessarily the most public health and sterile design of a bathroom to not have every aspect of it automated, to only have, for example, the tap or the soap dispenser or the toilet or the lights automated? Pay attention next time you walk into a public restroom. It's an interesting thought experiment. And this is segueing into the next lesson. If you're wondering how to begin having that mindset, don't think that inventors are just born. You can begin cultivating as soon as you step out of this classroom today by beginning to pique your curiosity. Begin to question everything. Always ask, what if? And how can I make it better? And what exists already, but how can I build on that idea? So look at the mundane, look at the everyday, look at the banal, and question it. I want to take you to this link here. Let's make it full screen. And so this is what is called the ketchup bottle problem. And so for those of you who've struggled to get ketchup or shampoo or whatever out of a bottle, again, MIT Media Lab said, well, why should you have to deal with that? And so they engineered a new type of material that has very little cohesion with whatever surface it contains. And ketchup bottle problem solved. The other part of the mindset I want you to take is seeing any problem and seeing it not as a problem, but as an opportunity to solve something. There's no such thing as a problem, but an opportunity, or to coin my favorite Simpsons term, a crisis-tunity. The reason that problems exist is because no one has found an idea to manage it accurately. It's just another problem waiting to be solved. So always play that what-if game with yourself. Always say, well, this isn't the most ideal design, or this isn't the most efficient process. What would make it better? Also, I want you to get out of that mindset, if you've ever thought it, that, but I'm only X, I'm only an undergraduate student, I'm only a science major, what do I know about business? I'm only in business, what do I know about science? Never ever underestimate your station in life. And so I want to take this time to tell you about two amazing individuals. So this is Jack Andraka. He's, I think, about 16 or 17 years old right now, but this is him at age 15. And he was a simple yet bright high school student who was personally affected with a close family friend dying of pancreatic cancer. And he was extremely frustrated with current pancreatic cancer disease screening techniques because for those of you who haven't heard much about it, it's an extremely aggressive form of cancer. The problem with it is by the time it's detected, it's too late because it's spread so far. And so he said, well, what if we could do better? What if we had better detection techniques? And so he said something ridiculous. The number I think he quoted was 4,000 papers. He looked through 4,000 scientific papers on the internet looking to see what exactly the state of pancreatic cancer detection research and technology was. Then he came up with a proposal, a timeline, a budget, and then he turned his idea into action. He emailed 200 research facilities, professors, institutions across the states. He told us that he got 199 flat-out rejections and one lukewarm maybe. Luckily, that maybe happened to be at Johns Hopkins Institute or Medical School in Maryland. And it was one of the lead researchers in oncology there who said, okay, well, your idea is intriguing, so will you come out and talk to me about it? And when he recites the story, he said that it was just him, and then they marched out team of experts in oncology and pathology and pancreatic cancer and just fired questions at him, one after the other, and he was sweating bullets. But by the end of it, they said, okay, agreed to take you on to do your research. And by the end of it, he had created a test using carbon nanotubules that bind to a marker on pancreatic cancer cells that is thousands of times cheaper, thousands of times faster, and better than the current gold standard for detecting pancreatic cancer. And what I wanted to show you now is his reaction when he won, because it's priceless.
Okay, here you go. This is our moment you missed. He's not on the Golden Gate Bridge. Pancreatic cancer is one of the most difficult cancers to diagnose, but thanks to this 15-year-old boy, spotting it just got easier. Now, enjoying his celebration there is Jack Andraka. Just won the world's largest science fair by creating a new test for pancreatic cancer. 38,000 Americans will be diagnosed with the disease just this year. About 34,000 will die from it. Andraka's dipstick sensor could make a dramatic difference. 100 times. Get that 100 times more sensitive, Lisa, than the current test. So he should be celebrating. That's pretty cool.
Yeah, and you know that test, it only costs pennies. For his work, I was looking this up online, reading it up online, John. I think he gets a $75,000 prize. So not bad at all, John.
A $75,000 prize and a down payment, I bet, on a continuing career. Hopefully.
And the other lesson from this video is it's okay to be passionate about your work. And so I alluded to this, this next lesson when I was telling you about my own work with Civic Art and disaster response. For those of you who might have an idea you've been sitting on for a while, but think to yourself, okay, even if I have an idea, even if I have the skill set, there's many other skill sets I don't have, and think, yeah, but. What? If you don't have the skills, someone else out there does. So find the right people. It's all about creating the right team and the right set of people. The reason that we don't have rocket surgeons out there is because there's people who are rocket scientists and brain surgeons. So there's people who are out there who are willing to help you with your idea. You just need to go out there and ask, and never underestimate the power of people and finding that right coworker, or teammate, or co-founder, or co-inventor for whatever idea it is that you have that you want to enact. So we kind of alluded to this when we were talking about, again, about social media, smartphones, and the technologies that we embraced with CivicGuard. Look for emerging trends and technologies. You know, read about whether it's in the daily news, read about new research developments, read about technologies, read about what's the latest and greatest in visual technologies and smartphones and medical research, because that's how you start getting the gears in your own mind turning. And look for trends. So we talked about smartphones earlier, that's one of them, but look at communications and social media. Look at how long it took the radio to reach its many millions of users. So to reach 50 million users, it took the radio 38 years. By comparison, Facebook only took 2. So the other lesson I want you to glean from this is the practice of thinking exponentially. Don't just ask, what if I took 8 steps across this room in an arithmetic fashion, but what if I did in geometric sequence? What if I doubled that number each time? What if I took 8 geometric steps and I doubled 1 to 2 to 4 to 8 to 16 to 32? By the time you reached 8, you'd be a lot further than across this room. And so just to let you know about other trends, some of which we already talked about, some of which we are going to mention here, trends that you can look into, whatever strikes your fancy to get your own gears turning. Big data. Has anyone heard of this term? It's a handful of you. So it's becoming more and more in the common parlance, but as early as 2 years ago, it was a completely new foreign concept to the average user in terms of, if someone said, oh, look at the big data that's being generated from, Facebook, from social media, from maps. The term refers to the vast amount of data that we're creating on a minutely, hourly, even secondly basis as human beings I'm sure many of you have come across the term or the research stat that over the past 2 years, over 90% of human data has been created versus the rest of history. And so what can this data be used for? When you look at the amounts of video data we're generating, the amounts of tweets, Facebook posts, the amount of traffic data that we're generating, the amount of sensors that we're putting out there, is this all just white noise and that we're increasing tremendously? Or is there a use for it? Can we use the patterns in the way that people interact, the way that traffic works, the way that traffic flows? Can we use that for the good? Can we use the way that people tweet at certain times of the day or the words they use? Can that be used for good? And to give you an example, several research facilities, both in the UK and the United States, have taken to data mining social media posts for words that track mood. And then they've used those words to correlate it to the geography of their respective nations. And so they've created a mood map, essentially, of the United States of the UK, and that's pretty cool. And what if you take it one step further and say, okay, I noticed that, when the weather is like X, that people seem to be in this mood? Or what if when people are in this kind of mood, they tend to buy product X more, they tend to have these buying habits. And so that's how we take this data that we're generating and turn it into something applicable. Several trends I want to mention to you in the realm of medicine, my own sphere. So in surgery, we're always seeking to have less and less of an impact on the patient. We love operating, but we're always keenly aware of the side effects of operating, whether it's an infection, whether it's pain that the patient experiences after an operation. And so we're looking at ways to maximize the results while minimizing the pain, and minimally invasive surgery is one of those methods, and that by decreasing the size of the incision that we make in our patients, whether it's for a craniotomy, for spine surgery, for an appendectomy, we're minimizing pain and healing time for our patients. So that's kind of one of the trends towards smaller, faster, better, cheaper. For drug therapies, we're looking at things that are more targeted. We're looking at things that act more quickly. Small nanomedicine also ties into this idea of smaller, looking at drugs that act not just at the systemic level, but at the cellular level, at the molecular level, that act at the gene level. I also want to bring your attention to what is widely known as the 4 Ps in U.S. healthcare. It stands for preventative, participatory, personalized, and predictive medicine. So how do you apply these concepts to make medicine better? How do you take generic advice, like take 2 Tylenol, call me in the morning, to saying, well, maybe your gene type doesn't respond so well to Tylenol, take 2 ibuprofen and call me in the morning. Focusing on preventative medicine, the best thing is if you can avoid seeing the doctor in the first place. How do we get people to care more about their own health, live a healthy lifestyle, live that healthy lifestyle like I referred to in the beginning of the talk, about eating better, sleeping better, taking stress off, and exercising, so people can live longer, healthier, happier lives. Because if you're 60 years old and you're living your life in a hospital from doctor visit to doctor's visit because you're plagued by COPD, heart disease, obesity, can you really call that quality of life? So these are just food for thought that I want you to get you thinking about as you walk out of here today and as you get ready for next week's or next session's class. So, told you what I want you to glean from this lecture. So let's bring it all home now today. So I want you to think big. Remember that nothing's impossible. Impossible is nothing. Always ask, how can I make it better? Question everything. Remember that there's no problems, that everything is simply a solution waiting to happen. Never underestimate yourself. Never underrate yourself, never underrate your station in life, and that never give yourself the excuse, but I'm only X, but I'm only so young, I'm only so old, I'm only a first-year undergrad, or I'm too ensconced in my career to leave now. Don't let that hold you back. If you're afraid that you as an individual don't have the tool set or the skill set to make your idea or vision reality, find people who can. That's what the world is full of 7 billion people for. And always read, educate yourself, become the expert in whatever it is you're passionate about. Never think you can know too much. Find out trends and technologies and stay ahead of them. And then go one step further and ask yourself, what if I could do this with technology X? So the last thought I want to leave you with today is, why innovate? Why bother to ask, how can I do things differently? How can I do it better? I think the answer is to make a difference. And so I'll leave you with this video here.
This thing is going to change the way that people have nights. Solar bulb is a cheap way of allowing light to go through your roof. By putting this on the roof, it goes through the bottle. The water serves as a thick lens, and it enters. And once water hits water, it refracts. So it goes 360 degrees. So it lights up a whole 35 square meter room in a very big way. That's 55 watts of free electricity. So what you save during the day, you can use for books, for school, transforming society as we know it. And if you can improve a life of a family, even in the smallest way, but make cumulatively many, many people be able to benefit from this, you change a whole new generation. They can read, their better nutrition, and the same thing is you don't have to spend money where it's not necessarily. And that's the gift of the solar bulb.
So do you remember what I said at the beginning of this lecture? The world is amazing, and there's potential in everything and everyone. So pop bottles can become light sources for those who can't afford electricity, simply by filling it with chlorinated water and then drilling a hole in the tin roof, sealing it, and allowing the sunlight to refract through. You can create more luminosity than your average light bulb. And so that's what I want you to walk out of here. If you remember nothing else, the world is amazing. There's potential in everything and everyone. Okay? So last questions I have for you. What I want you to start thinking about today. In our lifetime, will we cure cancer? Will we cure AIDS? We haven't yet, but we're coming close. AIDS is no longer a terminal illness, but a chronic disease. Will we eradicate polio? Again, we haven't yet, but we're coming close. Will we end our reliance on fossil fuels and oil? Will we stave off climate change? Will we bring the bottom billion out of poverty? Will we provide universal health care? Will we settle Mars? Will we reverse engineer the brain? Can we make ourselves better? Can we augment our memory, have photographic memory? Can we have telepathic communication? Well, we saw in the beginning of this lecture that the University of Washington, they're already doing it. Can we solve aging? Some people don't think it's a problem. Other people think that we should live forever. Okay, so next time, for those of you who are back Thursday, we're going to talk about taking big ideas and turning them from idea to reality. We're going to talk about thinking at big scale, 10,000, 10 million, 1 billion people. Talk about idea generation, working in teams, rapid prototyping, and taking an idea from simple idea to business. And then we're going to play business plan Mad Libs. All right, so just a summary of the homework assignments I mentioned to you throughout this lecture today, so all optional, but for a day, I want you to take a piece of paper and a pad, pencil and pad of paper and walk around thinking about all the inefficiencies in the world you see, and just write them down. Within your own field, ask yourself, what are the biggest 3 challenges that have yet to be solved? Is it a problem that's at the grand scale? Is it a problem with the technical part of your field? If you're a biochemical researcher, is it a problem with imaging and the methods that you use at your lab? Start thinking about the biggest problems that face humanity. Think of a well-known inventor and just take tonight to read up on them, whether it's Wikipedia, whether it's an autobiography. Look at Da Vinci, Edison, Bill Gates, Ben Franklin, and see how they lived. The autobiography of Ben Franklin is fascinating, the way he lived his life and the things he did from the printing press to the stove. Just learn how they think and learn how quickly they acted and pivoted. And then take a look at a PDF. It's online for free. It's called The Architecture of Invention. It came out of a Harvard MIT workshop. It's about a decade old now, but it's still fascinating. So staff and faculty from Harvard and MIT, they got together for a workshop, and they looked at characteristics that make inventors. They looked at characteristics of inventions, looked at personality traits. It's just a 31-page double-spaced PDF. It's a quick read, but very fascinating. Okay? My parting advice to you. It's a compendium of all my people I look up to. So Dean Kamen, George Bernard Shaw, Peter Diamandis, Steve Jobs. Remember to ask those fairy tale what-if questions. Stay hungry, stay foolish, because today's craziness might be tomorrow's breakthrough. When embarking upon an idea, ask yourself, is it crazy? The answer should be yes. And if it works, will it be a really big deal? So look at the world and don't ask why, ask why not? Because progress doesn't depend on the unquestioning individual, but the one who's unreasonable, who dares to ask questions. So that's it from me. And speaking of questions, we have some time left. If you have any questions, I'm happy to take them.
Questions, anyone? Come on, there must be.
I saw a quarter raised hand. Someone looked like they had a question and then put it down. Anyone?
Yes.
I just have a question about your whole social media innovation. Wouldn't that kind of transparency and like that much information spread out cause some sort of mass hysteria and like have a negative effect? Did you guys look at that?
Are you talking about CiviGuard?
Yeah.
Yeah, so that's a great question. So it's actually, your question is very relevant to existing systems, because our problem was they give information. So you look at existing mass messaging. So going back to that example of that screenshot I have of the San Mateo service, they said there was a blizzard. What does that do? But we feel by empowering people and giving them circumstance-specific information. So for example, you're in San Mateo County, and here are the major highways in your area that have been blocked off. Here are alternate evacuation routes. We felt that we could circumvent that problem by giving people not only information, but actionable information. So we felt actually rather just the opposite.
And there wasn't like bureaucratic red tape that you had to like stumble over, because I feel like that level of transparency isn't like...
Oh, there's a ton of red tape.
Yeah.
And that goes back to perseverance. I mean, when you're dealing with government, who our primary customer was, when you're saying that, hey, we have something that we think could really help people, the governments would always say, whether it's state government, local government, even the White House, they'd say, yeah, we agree, this is great, but it's 2009, we just came out of the 2008 budget or economical crash, we don't have the budget for this. So it goes back to perseverance. You have to be endured to kiss a lot of frogs before you can get that one happy answer.
Absolutely, thank you.
Great question.
So any other questions?
Did someone over here? No?
My question specifically about the biotic arm you were talking about for soldiers.
About what, sir?
The biotic arms for
Yeah,
soldiers.
the DARPA bionic arm. Yeah.
I don't know like how well versed you are in the technology, but I'm just wondering like how common is this technology? How many people have access to it? And like what's the potential to expand that? Because I think that there's obviously a lot of victims from war in other countries, and not just the soldiers of America. So, and other people that just have accidents. So how it like
Yeah,
what's the likelihood?
That's a great question. To be honest, I've paid more attention to the invention side of it, not so much to the marketing side of it. Are you going to be at next week's or on Thursday's session?
Yeah.
I'll look into it and I'll get back to you.
Thank you.
Yeah, it's a great question.
So I'll tell you something interesting about this course that we've discovered this term. That is that there's nobody in this room after us. That's the first thing to know. So you don't have to leave immediately. On the other hand, the videographer's task here ends when the class ends in 1 minute. So the video recording will stop in 1 minute, but you guys don't have to immediately leave. I don't know if Dr. Pandya has to leave, but anyway, it's kind of a relaxed end. It never occurred to me in this very desirable room that we'd ever end up in a circumstance like this of no other class coming in, but that's okay. So Shawna, thank you very, very much for an outstanding lecture, and if you want to stay, that would be fine.
Thanks for having me, Kim. If you have questions, I'm around for a few minutes after, so you can come talk to me. And my email address is there. So thanks a lot, you guys.